I want to show you some example of reaction problems or titration type problems that involve solutions. Alright, so the first one we're looking at is number 14, and the question is a 25.00 ml sample of HBr is titrated with 34.21 mils of 1.50 molar solution of sodium hydroxide to endpoint. What is the molarity of HBr solution? Now, if we're talking about endpoint, that means we're going to add just enough HBr to react completely with the sodium hydroxide. So that will make this stoichiometry matter. So 1 mole is going to react with 1 mole. Now, I'm not going to say we're actually going to end up with 1 mole, but whatever many moles react with NaOH, that's the same number of moles for HBr. So this is going to still work out for our purposes. Alright, so we've got to figure out what we're going to be starting with and what we're going to be finishing with. Now it says that we've got a 25.00 ml sample of HBr and that we're looking for HBr. So we know we're not going to start with HBr. That means we're going to have to start with the sodium hydroxide. And sodium hydroxide I'm going to assign to be letter A, and HBr, because that's all I'm looking for, I'm going to assign to letter B. The other big clue here is that we've got 2 pieces of information about sodium hydroxide, so there's another clear indication we're going to have to be starting with the sodium hydroxide. Now, in order to do these kinds of problems, I like to use a modified flowchart from my stoichiometry chapter, and that's QA gives moles of A gives moles of B, and that gives Q of B. Now Q here means quantity. So what we're saying is we're starting off with something, a quantity of A, we'll convert that to moles of A, we'll convert that in turn to moles of B, that'll be using the reaction, and then we'll get a quantity of B out of that at the end, depending on what we're looking for. Now the first step then is to try and get moles of sodium hydroxide or moles of A, and to do that I've got a volume and a concentration. Now as I have said earlier, we know that concentration is moles per litre. That means if I want moles, then I'm going to have to take the concentration and multiply it by litres. Now here I've got a volume in millilitres and a concentration in moles per litre or molar. So I know I'm going to have to end up multiplying these two to get where I need to be in the first step. So that's what I'm going to do. I'll start off with the concentration, but I could have started off with the volume as well. It really wouldn't have mattered. And I'm going to make it moles of A over litres of A. I'm going to multiply that by the volume. And then I'm going to, I'll just make myself a little bit more room here. Alright, now I'm going to convert that into litres. And all of this was with the aim of getting to moles of A. See, this will cancel, this will cancel, this will cancel, and this will cancel. Alright, so just summarising what I've done so far. I know I wanted moles of A in the first step. To get there, I knew I'd have to take the concentration and multiply it by the volume. Unfortunately, I had millilitres and litres, which meant I needed to do a conversion. So I did millilitres, down here 1000 millilitres of A and 1 litre of A on top. Right, that gives me moles of A. My next step is to go to moles of B. And to do that, I'll need the stoichiometry of the reaction. Now I know that 1 mole of B will react with 1 mole of A. And the moles of A is going to go on the bottom, so it cancels with the mole of A here. Now what I've got is moles of B. So this is where I'm at now in the flowchart. Now what I need is the molarity of HBr. Molarity is moles per litre. I've got moles, but I need moles per litre. How do I get there? Well, I know that I've got moles here. I need litres on the bottom. So what I'm going to do is multiply it by 1 over the volume given for B, which is 25.00 mils. Now the times 1 over part, the 1 has no units next to it. All I'm doing is taking the moles and dividing it by the volume. So times 1 over something is the same as dividing. So moles over milliliters. But I don't need moles per milliliter, I need moles per liter. So that's why I'm going to do a conversion. So it'll be 1,000 mils. Whoops. 1,000 mils of B over 1 liter of B. And you can see that that will allow me to cancel the milliliters. And what I've got now is 1 mole of B over 1 liter of B, or moles of B over liters of B. Now when I do all the math here and multiply everything out, I'm going to come out with 2.05 mole per liter of B. So there's the answer for that one. So that's for 14. Alright, let's look at 15. How many grams of CaCl2 are needed to completely react with 250 mils of 0.750 molar AgNO3 solution? Same kind of problem initially. We've got a volume and a concentration of AgNO3. We know we're after the CaCl2, so I'm going to put a B there, and I'll make that an A. And what I'm going to do here is go ahead and do this out. And we'll start off with the volume this time. And this is going to be A. And I'll multiply it by the concentration. The concentration given is 0.750. Moles of A per 1 liter of A. Now at the moment what I've got here is I need to get to moles of A, but I've got milliliters of A and liters of A, so I will do a conversion to get rid of that. Oops. And that would be 1 liter of A, so that cancels, and 1,000 milliliters of A. So that cancels. That's milliliters of A, that's liters of A. Alright, so now we've got, we're going to have moles of A. Our next step is to get to moles of B. Now we know that 1 mole of B reacts with 2 moles of A. And then our next step is to figure out what we need for moles of from the moles of B, and we need to get grams of CaCl2. So we know that we can cancel out the moles of B if we put moles of B on the bottom, and we know we need grams of B on top. And this relationship here of grams of B to moles of B is familiar to us. We know that it's molecular weight, and I'll let you work out the molecular weight of that. And that's the molecular weight of CaCl2. And that final answer is going to end up being 10.4 grams of CaCl2. Alright, so in that final instance, what we needed was to cancel the moles of B and be left with grams of B. So that's how I knew to put moles of B on the bottom and get that cancelled. And you see the moles of A ends up cancelling over here too, of course. So we end up with getting just grams of B as our final answer. Alright, let's take a look at number 18. What volume of a 1.50 molar NaOH solution would be needed to react with 250 mils of a 6.0 molar H2SO4 solution? Alright, so again, we're going to use this flow chart, and our first aim is to get to moles of A. So we're looking at A. A is going to be H2SO4, and B is going to be NaOH. B is what we're looking for, what volume of NaOH. And we've got plenty of information about the H2SO4, so we know that's what we're starting with. I'm going to go ahead and start with the concentration of that. So 6.0 moles of A per liter of A. So we're just taking the molar, converting it to moles per liter directly. Oops. We're going to multiply that by the volume, which is 250 mils. Now remember, the whole point of this is to get to moles of A. At the moment I've got liters of A times milliliters of A. Remember, we're doing this because moles equals concentration times volume. I'm going to have to do a conversion here, and I'll do 1 liter of A over 1,000 mils of A. Alright, so we'll cancel all that, and we've got our moles of A, which is where we want to be in the first step. The next thing we want to do is try and get to moles of B. Now we can see that 2 moles of B will react with 1 mole of A. Alright, so now we're at moles of B, so the moles of A will cancel here. We've got moles of B. And we need to get to now the volume. We need the volume of sodium hydroxide. And what we've got here is we've got 1.50 molar sodium hydroxide. Now 1.50 molar, that's moles of NaOH per liter of NaOH. Alright, so we've got moles per liter. That's what this represents down over here. Now remember, I want liters, so what I'm going to do is I'm going to put moles of B down here because I want that to cancel. And I want liters of B on top. So we need a relationship between liters and moles, and we do have one here. We know that 1.50 moles of sodium hydroxide is in 1 liter of sodium hydroxide. So what I know is that 1 liter is 1.50 moles. And that will give me my final answer, which is 2.0 liters of sodium hydroxide. All right, let me explain a little bit more about this step here. If I've got moles and I want liters, from up here we know that concentration equals moles over liters. We also know that liters will equal moles over concentration. So effectively what we're doing is we're taking the moles and dividing it by the concentration. Now the same thing as dividing by the concentration is multiplying by 1 over the concentration, which means we're flipping it. So 1.50 moles per liter becomes 1 liter per 1.50 moles. So it's times the inverse of concentration, or the flip of concentration. And that's why we're flipping it. So that's the other way of looking at it. So you can do it just by figuring out the dimensional analysis and knowing we had to get rid of the moles of B and leave the liters of B on top. But the other way of doing it is to know that liters is also equal to moles over concentration, or moles times 1 over concentration.